Hello guys, welcome to Let's Learn and Explore. Today we are starting with 10th Mathematics series, Chapter 1 Real Numbers. Let us take a brief introduction about the real numbers. What are actually real numbers? Real numbers are any value that can be represented on a continuous number line. What do you mean by a number line? Let us take a clamp. It is a number line. Here is a neutral point 0. Right of the 0 we have positive integers like +1, and left of that 0 we have negative integers like -1, -2 up to -infinity, and here up to +infinity. And what are real numbers composed of? They are composed of both rational and irrational numbers. You know what are rational numbers? A number that can be expressed in the form of a by b form, where b should not be equal to 0. A and b are cofactors or co-prime numbers. Here, what are irrational numbers? Which cannot be expressed in the form of p by q. Like √2 is an irrational number. √2 is irrational number. Also, it can be called as real numbers. Okay. Real numbers can be positive, negative, and also 0. Now, let us learn what is not a real number. Complex numbers which cannot be plotted on a standard number line. We have already seen the standard number line of positive, negative, and 0. Here, which cannot be expressed on the standard number line are not real numbers. Best examples are complex numbers that cannot be plotted on a number line. For example, -√1. Root of -1 cannot be plotted on a standard number line. Okay. Then one question arises here. Is root 0.5 a real number? Of course, yes. More specifically, it is a rational number because 0.5 can be expressed as a by b, that is 5 by 10. I think you got what real numbers are and what not the real numbers are. Okay guys, also we have a very basic idea in this chapter. This chapter actually starts with a fundamental theorem of arithmetic. Okay, fundamental theorem of arithmetic. What does it say? It says that every composite number can be factorized as a product of its primes. Also, a prime factorization of a natural number is unique. This is very important here, except for the order of its factors. Very basic example, 32 can be expressed as 2 16s are, 2 8s are, 2 4s are, 2 2s are, 2 1s are, 2 2s 4, 4 2s 8, 8 2s 16, 16 2s 32. These are the prime factors of 32. This is the very basic and fundamental theorem of arithmetic. Here, one more concept is there in this, that is LCM and HCF. What does LCM means? It is a longest common multiple. What is HCF? Highest common multiple. Let us learn what HCF is basically. It is 6 and 20. We can find the HCF of this both the numbers. We can take 2 as starting, 2 3 6, 2 10s 20. Now we can't take 3 here because 10 is not come under 3. Okay, only 2 is the highest common multiple. Therefore, the HCF of this both the number is 2. I think you got the HCF. Also, how can we find the LCM of both the numbers? 6 and 20. We can take 2 here. 2 3s 10. 2 3s 6. 2 10s 20. Also we can take 2 here because it is the longest common multiple we are taking here. 2. We should keep 3 as it is here. 2 5s 10. Now 3 and 5 are prime numbers. They 3 ones, 5 as it is, 5 1 1. Let us find the LCM of both the numbers by multiplying these common factors. 2 into 2 into 3 into 5. We'll get 2 2s 4, 4 3s 12, 12 5s 60. Yes, the longest common multiple of this both the numbers is 60. Okay, we got how to find LCM and HCF of the numbers. Now a very basic introduction is completed and we can move forward to the chapter. Here is one formula in this chapter. This is the main important formula. We'll get 2 mark question from this chapter, that is to find the LCM and HCF or the number which have given. Okay, this is the very 2 marks basic question which will be asked in your board examination. Compulsory question. You should learn this. If you learn this, you will get 2 marks for sure. Guys, please subscribe. This is my first video. If you given support, this will be continued forward and important questions will be uploaded very soon. Okay, and we'll move forward to the formula of this chapter. For any 2 positive integers a and b, how do we find LCM or HCF of these both the numbers? By using prime factorization method we can find. But if the HCF is given and LCM is given, one positive integer is given, how can we find the another positive integer? Yes, this is the basic formula to find that. HCF of a positive numbers and LCM of the positive numbers, both the product will give you this multiple of the 2 positive integers. LCM into HCF will be equal to product of both the numbers. If we needed LCM over here, we should multiply both the integers. We should divide those by the given HCF. If they given the HCF, we should reverse this. A by B, A into B divided by LCM of that number.